Thanks, everyone. Pretty excited to be giving this talk. Last time I attended Data Insights was in Melbourne in 2022, and I'm pretty sure there wasn't an AI ML track. So great to see that now we have our own AI day. And shout out to Peter and the rest of the team for putting such an amazing conference together in such an amazing venue as well. So a little bit about me, because my job title might be a bit misleading. I'm a senior data and AI engineer at Versent. My background is in stats, data science, and data engineering. A bit about my experience. In the past, I've done a lot of work around data, ML, and MLOps, mostly on the AWS and Databricks ecosystems. In the last couple of years, though, I've shifted a lot of my work towards Gen AI engineering. So, for example, building RAG systems, but as well AI governance and AI assurance. Some other areas that I'm also very interested in include AI ethics, data governance, and responsible AI. So here's a rough agenda for the talk. I have a bit of a confession to make. The reason why I decided to come up with this talk is because I was so frustrated with the overuse of the word AI agent. How it's been thrown everywhere, even though most software engineers and still many AI practitioners don't have a full grasp of the term. So I decided I would go down a rabbit hole to try to unpack this term and really find the substance within AI agents. This led me to autonomy and AI governance, both of which I'd worked with in previous gigs. Now, without a doubt, AI agents have capabilities that are unprecedented. We've seen that over the last 2 days, and you've played with the latest agentic workflows and tools. So my intention with this talk is not to sell you AI agents, but instead share the latest research and insights around agents, autonomy, and AI governance, and show you how all of these are interconnected. I hope the message that you take home today is that good practices around AI governance is and will be one of the biggest challenges to bring in and keep in healthy AI systems in production. But before we go deeper into AI governance and autonomy, let's start with a question that we are all wondering about. What really is an AI agent? So when I started looking more deeply into AI agents, I found at least 10 definitions of the term AI agent, many of which contradicted each other. So I think most of us by now are familiar with the AI agent workflow, which is the diagram that you can see on the screen, whereby we have a user that prompts a foundation model. Around that foundation model, there'll be a scaffolding or orchestration layer whereby the model can interact with an environment. So for example, an API then gets a response, which is then downstream fed back to the user. So we know what an AI agent does, but what exactly makes it an AI agent? So for example, what about a traditional RAG? Would we consider that an AI agent? If not, what about a graph RAG? Is it only an agent if it interacts with an API? I think the answer for a lot of these questions is quite blurry. So instead of getting caught up in the semantical definitions of AI agents, I think it's a lot more productive to talk about the degree of agenticness of an AI system. And what I mean with that is that we can measure the main characteristics of this system. As you can see on the slide, mainly four, I'll go through them. First, goal and execution complexity, how complex the task at hand is, whether the task has to be divided into subtasks, how much planning the system has to do in advance, aka planning horizon, as well as the depth of reasoning for each of these tasks and subtasks. Second characteristic, environment and goals, the different areas and domains that the agent can interact in, as well as the ability to interact with external tools, as we've seen. The next is robustness, how well the AI system can adapt to changing conditions in its environment. So for example, if you're thinking of an agentic coordinate assistant today, if it gets an error during a build, is it able to find a workaround or not? And last but not least, autonomy, which is the ability for the system to carry its intended goal with minimal to no human oversight. So I think once we have these characteristics, it's a lot more clear to understand why AI agents are so unprecedented, mainly because they perform so well around these four. For example, if you compare an agentic coding assistant today to an early LLM-powered chatbot, you would agree with me that the agentic coding assistant today would outperform the other in all of these four characteristics. As I've mentioned before in this talk, I'll be diving deeper into autonomy, as I hope to convince you it's the most important characteristic for AI governance. Now, before I move on, let me clarify some semantics, because I think it's more productive to talk about the degree of agenticness of a system, as I've shown you here. I'll try to stick to the term agentic AI system, or system for short, instead of AI agents, but in the context of this talk, I might use them interchangeably. Also, I should mention that the focus of this talk is agents, not so much agentic AI, as Olena has walked us through an example, which is the next paradigm shift in frontier AI, where you have multiple agent collaboration. However, with this degree of agenticness way of thinking, you can think of that multi-agent collaboration systems as just having a higher degree of agenticness. And therefore, all of the lessons that we'll learn in this talk will apply to that architecture as well. So let's start with a question. How is autonomy relevant to AI governance? As the team from Hugging Face very eloquently put it, the more autonomous the system, the more we cede human control. Now, this is extremely important to understand, because any governance will always be about effective oversight and guardrails, whereas autonomy is about ceding control. So you can understand how these two might naturally be at odds. But if you still don't believe me, the Governance Institute of Australia and the National AI Centre released a white paper last year where they flagged this as quoting from the white paper, as AI systems become increasingly more autonomous and complex, the potential for unintended consequences and ethical dilemmas grow. So to summarize, the higher the autonomy, the higher the risk. We are already seeing examples of this, where, for example, an agentic coordinate system has deleted a production database. Now, this will keep happening with more autonomous systems and heavier consequences, perhaps even more implicitly, where we don't realize so obviously. So the question is, how can we mitigate the risks associated with autonomy? That's where AI governance comes into place. If you're unfamiliar with the field, AI governance is about providing the frameworks and guidelines to mitigate the risk of AI system development across the AI/ML lifecycle. Many of you will be very familiar with the diagram there. It's an oversimplification of how you bring an AI system from zero to prod. Now, I should mention that AI governance is about providing those guardrails and frameworks not only in the monitoring step, but across the whole lifecycle. So, for example, effective data processing will require an effective data governance. An effective model registry, model development and deployment will require something like a model registry, where you version control and tag your models. Now, to fully understand the challenge at hand, I would like to imagine the following scenario, which, by the way, is based on a real story. Imagine you're a mid to large organization with a few dozen AI systems in prod, and you're facing the following challenges. One, you have data and concept drift in some AI systems. Two, you don't have a centralized data or ML practices across the organization, but also across the lifecycle. In the meantime, you're developing agentic AI systems with higher degree of autonomy, but at the same time, you have a backlog of drifted AI systems that you need to review and improve. So here's the dilemma. How do you systematically know which agentic AI systems have a higher risk profile? Therefore, you should prioritize accordingly. Most of us are very familiar with the notion of a data swamp, and with the rapidly evolving landscape of agentic AI systems, I think this will be a very fitting analogy where we'll see many AI swamps across many AI organizations. So how do we solve this challenge of governance and prioritization? To even start addressing this challenge, let me flip the question on the slide's title. Instead of asking, how is autonomy relevant to AI governance? Let's ask the question, how is AI governance relevant to autonomy? And I think here's where we can learn a lot of lessons from data architecture and data governance. From a lot of our peers who have presented at this conference and in Melbourne, where taxonomy will always be crucial for any effective governance. And what do I mean by a taxonomy in the context of autonomy? Measuring the autonomy of an agentic AI system against a standardized reference point will give us a measure of the risk profile of that agentic AI system, which in turn we can use to prioritize governance. So for example, by tagging our models with a level of autonomy in our model registry, or even restricting the testing environment based on the level of autonomy. Now, autonomy will obviously not be the full risk profile of that agentic AI system. Ethics, for example, and transparency will come into play, but it's certainly a great start. So producing a framework to measure the autonomy of AI systems is exactly what the ISO 22989 set out to do in 2022, which for many of us will seem like a lifetime ago with the current AI product release cycle. This framework identifies 7 different levels of autonomy and the description associated with each level. So you have from level 0, no automation, all the way up to level 6, highly autonomous system. Now, this framework was a great stepping stone to make us think about autonomy in agentic AI systems. However, for me as an engineer, it's unclear how actionable this is. For example, for many agentic coding systems and agentic workflows, I would really struggle to place some of these tools between, say, level 4 and 5 or level 3 and 4, mainly because we only have a one-liner for each of these levels. So the question is, can we draw insights from other industries to iterate on this taxonomy and improve it? And the answer is absolutely yes, if you consider self-driving vehicles. This is exactly what the people at Interface set out to do with the collaboration of the Ada Lovelace Institute, who do a lot of work on AI research safety. They produced this framework this year, which is inspired heavily by the UK Automated Vehicle Act, which was passed in 2024. Now, the main benefit of this framework is that it showcases a lot more agentic scenarios and provides a lot more details around the different personas associated. So developer, user, and agent. Now, I won't go through every single box of this. You can probably not read it at the back, but I'll give you an overview by going through the different levels of autonomy that they identified from level 1 to 5. So level 1, reactive AI. This is a system that takes users' input, but there's no orchestration whatsoever. So think of this as your standalone LLM or even your classic machine learning model. Level 2, goal-oriented AI. Here there's some orchestration, but it's not driven by the system itself. So again, here you can think of your standalone LLM or your classic machine learning model, and then you build the orchestration layer on top yourself via, for example, a Lambda function or an Azure function. Level 3, we've got adaptive AI. This would be so-called tool calling agents, where the system is able to interact with external tools, for example, MCP. Level 4, semi-autonomous AI. Here, the system has a much longer planning horizon, and therefore is able to tackle more complex tasks. We've seen this a little bit with Claude Code, Gemini CLI, Deep Research, which would be scratching the start of this level. And then level 5, self-directed AI. Here, the system would be a lot more autonomous, essentially the next paradigm shift of frontier AI, where a lot of the control is ceded to the system. AutoGPT, or more likely a next version of AutoGPT, could be a candidate that would suit this level. So this framework is very well motivated and based on well-established research on an industry which quite frankly has had to wrestle with the idea of autonomy for a lot longer than we've had. However, I should mention that it was written more from like a legislation and policy angle, and therefore I think it has some limitations for our community. Mainly, I think the high ceiling for highly autonomous systems is not high enough. It's too low. For example, it doesn't account for multi-agent systems, at least explicitly. But most importantly, we are starting to scratch levels 4 and 5 of that framework. So I don't think this framework will be predicted enough for 2026 and 2027. So some other organizations have produced more actionable frameworks that will be closer to engineers' works, and hard probably as well. I will go through Hugging Faces 1, which you can see on the screen, which was released earlier this year, just a few months ago, as it has a lot of overlap with the previous one as well. It's really neat. They also identify 5 different levels. And the really nice thing about this framework is that they also included some very high level code, example code of what the logic of the agent would be for each level. So going through each of the levels, level 1, processor. Again, as the previous framework, here the AI system is purely a tool, such as standalone LLM or ML model. Level 2, this would be a router. This might be a more sophisticated chain where the AI system decides when to run its logic. Because some of the orchestration starts to be driven by the system itself, we see a higher level of agenticness emerge, and therefore the risk profile increases accordingly. Level 3, this would be tool calling agents, similar to the previous framework. Here the system can interact with external tools such as MCP, and even if the developers limit what functions and tools the system can use, the system can still choose when to use which functions and what parameters to pass. This is what I would expect from AI agents today, and it's when AI governance starts being absolutely crucial. Level 4, multi-step agent. Here the system has a longer planning horizon, where solving more complex tasks requires planning and dividing the work into subtasks. Here, which is extremely important to understand, the system has control of how long the task will take to complete, i.e. the runtime, and therefore interruption mechanisms are absolutely crucial. Here in theory, there's also the possibility that the AI system's goal would drift or change over time, especially for longer runtimes. And therefore, decision logging of the agentic AI system is crucial. Again, I would argue tools like Claude Code, Gemini CLI, deep research might start scratching the surface. So how to govern these systems is certainly tomorrow's problem, and we need to start solving it today. Level 5 would be fully autonomous agents. Here, the human has ceded complete control to the agent, potentially as well the infrastructure needed to run that system as well. This would correspond to next paradigm shift in frontier AI. Again, very hard to predict, but I would expect here that the system's goal would be extremely open-ended, and the runtime would be a lot longer, potentially spanning weeks and months. I think here the best we can hope is that there would be an emergency stop button, and it's also where a lot of the AI safety research is taking place at this level. So to me as an AI engineer and AI governance enthusiast, I think this framework gets a lot closer to something more actionable. However, the lens of this framework is still very much from that research point of view. This one in particular, as I mentioned, was released by Hugging Face a few months ago via paper. LangChain released a similar one on a blog post, so still very much at that research level. So here's my collective challenge to our community. Can we iterate this research and start turning it into a fully fledged adopted taxonomy? I think here's where we need to look at examples like Data Vault and Data Mesh, because they have shown that this can be done. You can develop and produce a methodology which, although might change over time, people and organizations really take on board and start adopting. And I hope with these three frameworks, you started appreciating a bit of convergence, where the last two are a lot more similar than the first one. All right, so I'm aware that was a lot of information to digest. So I'll start wrapping up by summarizing some of the challenges and opportunities ahead. So first, context. As pointed out by this quote from a paper, what is considered autonomous depends on the environment and constraints. Unfortunately, as we've seen with the case of self-driving vehicles, we can simply copy and paste an autonomy framework that works on a domain onto another. The concept of autonomy varies a lot depending on the domain, which will make it very challenging to come up with a domain-wide framework for agentic AI. Challenge number 2, user in charge. In the context of agentic AI system, I don't think we still have a fully fledged notion of who's in control and when. And as these boundaries will be quite blurry. Now compare it, for example, to the case of self-driving vehicles, which is not perfect, but at least there are more defined control protocols where you can say who's in control and when. So for example, you might say, once the human cedes control of the steering wheel and the brakes, then the vehicle becomes the user in charge. Next, rapid industry evolution. Our sector has become the fastest growing industry. I think this has shown throughout the last 2 days. And quite frankly, I think we all are struggling to keep up with the newest tools and workflows, which will make it very difficult for AI governance to come up with a framework that can catch up with the product release cycle. The next challenge is policy and legislation. And like for the case of self-driving vehicles, there's no extensive policy and legislation for agentic AI systems. Now, this is extremely crucial to understand because it's quite likely that in a year or two, some agentic AI systems will become or consider employees of some organizations. However, there's no currently legislation around the accountability and liability of the systems, unlike for human employees, which, as we see problems such as deleting a pro database, this will be more and more of a problem. And last, certifications and standards. Unlike, except from very few outliers, there's not really a culture of having standard certifications in the AI community. This is why I put yet within brackets, because I think it opens the door to a wonderful opportunity for us to learn from other communities such as cyber, where certifications and standards have been around for many, many years. Which is a good segue for the opportunities ahead. First of all, responsible AI. You can call me optimistic here, but as part of my job, I get to work with a very wide range of clients, and I still haven't come across a client who doesn't want to develop and deploy AI systems safely. And by the way, if you're wondering what responsible AI means, that has a very specific ISO meaning, which spans areas such as ethics, transparency, accountability, privacy, etc. Now, I think this gives us AI engineers and leaders a wonderful opportunity to leverage and really lead the way by showing what responsible AI looks like. As Joe mentioned yesterday, the future of AI governance is still not written. It's still up to us how we write that future. Next opportunity, recycling governance patterns. As I've mentioned throughout the talk, AI governance and data governance share a lot of similarities, and therefore there's no reason why we shouldn't implement some of the lessons learned in data governance. Now, that might not mean all of the lessons, but the ones that can really apply for AI governance. So for example, the lowest hanging fruit, I think, would be rigorous lineage and logging of AI decisions in agentic AI systems. Next opportunity, the benefits of AI governance. I've shown you multiple autonomy frameworks today, and although they might have some limitations, I hope it's clear to you that these frameworks allow us to move from vague marketing notions of AI agents to much more measurable, detailed, and actionable criteria. As I mentioned before, for example, you can feed these frameworks into your governance mechanism. For example, by tagging the level of autonomy in your model registry, so then you can prioritize your backlog of drifter systems, but also even restricting the testing environment of your systems depending on the level of autonomy. I think this is more relevant than ever because across all the frameworks that I've shown you today, it's already clear that we're developing intermediately to highly autonomous. The last one, developing human-centered systems. Now, this last point is crucial. As many organizations have pointed out, these highly autonomous systems we are already developing today might make mistakes that would lead to very heavy consequences. I think this presents a wonderful opportunity for us to implement human-in-the-loop mechanisms when architecting AI systems. I think by having a human in the loop, you are already implementing some minimal and default autonomy and governance into the system. But also from a systems design perspective, it's extremely important to remember, and I see this through my work, that it's much more valuable to build and develop AI systems that empower people in your organization and not replace them. So that wraps it up. Before I leave, I have a question that has been bothering me since preparing for this talk, and especially reading more about self-driving vehicles. So I hope it'll bother you too and spark some thought. So in the context of agentic coding assistance and workflows, at what point does the driver become the passenger? I'm going to let that sink in. So I hope you enjoyed the talk. Here are the reference for you. I don't think we have time for Q&A, but if you have any questions or thoughts, please feel free to approach me after the talk. I'll be at the Versent booth as I'm really passionate about this field. Thank you very much.